Not sure what this is. It's something about an operating system. The operating systems are getting newer and better. Actually, I wouldn't even say better. They're getting newer. They're doing more stuff. But what is it as a form of software that other software isn't? I mean, like, how is it separate from other pieces of software? Because if I have, and I did provide support for a company like this. It was a law firm that ran WordPerfect like 2 or something. And they were like full on running in MS-DOS or regular DOS, running WordPerfect and producing work in modern, in modern legal documentation. And I suppose you could put air quotes around the word modern, because most things legal are pretty ancient. But the point was, it accomplished the task that it was set to perform. Now, yeah, the newer versions of WordPerfect did this and that and the other, and they had graphical interfaces, and you could use a mouse, and. But that didn't matter, because it performed perfectly. It performed its task perfectly. So the question is, what do we ask of our software, and what does it need to perform, and what is the utility of an upgrade? From an operating system in particular, you ask that it relay, controls from your input device, your keyboard and your mouse, that it reads those devices, it sends input from them to various systems, and that it can run software and pass input from this to that, and you can get output out of it. Or in the case of a video game, for example, the video game was always kind of interesting to me, because it was all self-contained. You created an interface, you created a world, you created the graphics, you created everything that went into it, and everything that the user experienced. And for the most part, the game pretty much took over your input controls while you were playing the game. So when you start looking at things like older operating systems, you can ask yourself, what makes a perfect operating system, or what perfects the operating system, and what does the upgrade offer me? What does it provide for me? Because when you get into, especially in systems where you're doing manufacturing, you're doing actual work, you're only asking 1 or 2 basic functions out of something, you have almost nothing to gain and potentially a lot to lose by performing these upgrades, or by really making any changes to these systems. I say this as I am in the process of upgrading some of our systems. But it's like, if it does what we need it to do, and it does it well, and it doesn't crash, and it doesn't need Windows updates, and the people on the line aren't going, well, it restarted last night and I have to log back in. Why did it restart? Well, it's done restarting, but now this doesn't work, and now I have to go back and figure out what's going on with it. That's something that's actively hindering you. So I guess I'm thinking of more single-purpose machines. Even in the case of like a hospital or something like that. In the case of a hospital, you're processing, you process lots of stuff, pretty much everything, really. But there are instances where individuals are basically looking at a PDF and setting codes in a code system. And that's about as simple as it can get. That job is repetitive to the point of banality, but it's a single process. You're asking only one thing, or 2 things really, of the system. So installing a full version of Windows is a detriment to performing those tasks. Writing your coding software for Windows is a detriment in a lot of ways. Frankly, you might have a better time, I'm going to say it, writing it in Java, just for the just to be able to go back and forth between systems. So you write it once and then anyone can use it. But why would you? And then there's like licensing. Oh man, if you've never had to handle licensing or software licensing, especially for Microsoft, just count your lucky stars, if that's still a saying. So the question gets to be, why not just write your own operating system that performs basic functionality, basic functions? And that's tempting, really, and it has been done in some respects. It's technically not that hard. I mean, it's difficult. It's not impossible, is what I'm trying to say. It's not extremely difficult. How's that? So if you have something that's just managing these inputs and these interfaces, it should just run, right? Well, maybe not. When you write the operating system, the new operating system and the new versions and the upgraded versions also add hardware support, newer hardware support. And that gets to be an issue if you're running into instances of legacy hardware where things aren't really, where you just can't buy it anymore. You have systems that you can't buy parts for because the systems are 20 years old and it just doesn't exist, or it's impossible to buy it. Or, there could be patent lawsuits or something that prevents it from being sold. There's also the interoperability problem. Because in most cases, and this is why things tend to standardize, in any networks, things need to have some standardized form of communication, and TCP/IP is just fine. You're sending data back and forth, but you still need standardized formats. And a WordPerfect 2 document doesn't really get you very far. If you could turn that, if you could add some modernity to that and export as a PDF, now we're talking. Because then you can, even something as old as FTP, file transfer that file around and do what you will with it. More of the modern printers even support FTP and PDF as standards. So you don't even need print drivers. You can FTP a file to a printer, and then the printer will automatically print that out next cycle it checks. So that's pretty cool, and you don't have to worry about drivers at all, which is pretty neat. But the potential for, your hardware failing at some point, or your hardware just wearing out to the point that you can't replace it and not being able to replace it, is the problem. Because we are talking about ideally infinitely running systems. Something that's just going to keep on running till doomsday. It's not going to have a problem. I hear interesting things from the post office as far as their systems, which are in technological context, ancient and still running great. I've also heard really weird things about floppy disks, and I mean 3.5 disks that run for decades, which is not something that I imagined was possible, but apparently, from what I've heard, it is the case. So that's kind of interesting. But the ability to have, it seems like you need kind of a virtual environment set on top of it, a video game, for basically, where it's going to take over the operating system or take over all the user input, and then you can just do whatever you want with it. I mean, Java really does seem like the correct place to go. Thinking back, there's a modern Smalltalk implementation, and developing this stuff or working on these kinds of tools, you can still have plain text file formats. CSV files are transferable. Any type of REST API opens up pretty standard network interfaces. You know, any system that you can run a Python, you know, any system you can run a Python engine on, I mean, technically that should be able to do whatever you want it to do. It's interesting. Anything where you want it to take over the display driver and take over all the input. It's interesting. And what I'm talking about is, you know, it's not going to be heavy duty. It's going to be very lightweight, very simplified, which means that it doesn't really need excessive system resources. So it's not a huge deal if you just run it on top of another box. Or, well, virtualizing it would be a great idea. Just trying to think. I mean, part of this is a process improvement, because your process needs to be designed such that pretty much anyone can use it. And the more options you build into a process, the less obvious, I guess, the less obvious it becomes. Your process needs to be basically a one-way path, that when you complete the process, it brings you back to a fork, you know, a menu. And then from that menu, you select your choice of path. You loop around that path, and then when you're done, you get out and go to the menu and choose a new path and loop around that path. It just makes things easier, and you don't have to worry about OS upgrades or any of that garbage. And then you can run any kind of OS you want. New, old, you know, it all has to be backwards compatible though, so. Just want to simplify. I want things to be easier, and I want to be able to write something that will write something that's future-proof, that will run on future hardware, no matter what that hardware winds up being. And a virtual machine seems like the right way. Even the Java virtual machine seems like the right way to do that, especially if it's lightweight enough. I don't know how fast we can make something like that.